Hey guys, today we're going to be unboxing Diablo 4.
Man, it's a robot.
I'm unboxing a robot? Oh god, my notes are going to be all wrong.
Be more prepared next time.
Today we have the new Direct Drive Tech Diablo robot. It's a whole robot. I think that's pretty awesome. It comes in this massive case, which I can barely lift by myself. I'm super excited. Direct drive motors are a really, really cool technology, and to see them integrated completely into a robot like this is awesome. It looks like the case here is a really big and beefy aircraft grade like gear case thing. It's got these giant metal buckles on the front. Oh, look at this. It's padded at the top. We've got a little bit of a sheet, I guess, outlining what the hell the robot is. Got some panels here protecting the top of it. Nice foam and plastic stuff. Oh my God, look at that thing. Oh, it comes with snacks. Got a manual here and what looks like a really neat little multi-tool as well. It comes with a briefcase. Oh, okay, cool. We got a controller. We have, I guess, a plate of some kind. Seems to have the serial number. A little bit of a toolkit with some extra screws and bits and bobs. Big old charger, because this is not a sitting robot, it's a driving one. Really, really nice little metal briefcase. And I guess now for the main event, let's see if I can get this thing out of here without destroying it. Oh my God. Is that impressive or what? Oh, Jesus, it's really heavy. Oh, sit that back down. Oh, that's gonna be sick. Holy crap. This is a fully featured robot. This isn't a toy, this isn't anything like that. This is a real piece of machinery, and it really feels like it. Got carbon fiber pretty much around the entire thing. The whole base plate's here made of carbon fiber. Front panel here is made of carbon fiber. So we've got these skateboard wheels on the bottom here because it has a couple different modes that it can live in. It can sit down on the ground like this and roll back and forward. And then, of course, it can also stand up. We'll see that in a minute. Very excited to see this. Because this is direct drive tech, they sell direct drive motors. And this one seems to have 6 direct drive motors, which is really, really awesome. So the wheels themselves are actually motors, as well as these knee joints here. And then there's another one which seems to be in the top here. And it's got another pair right here, which drive these motors for the rest of the knee assembly. We've got some really cool like arm articulation things here. We have one point of this little fork attached directly to the outside of the motor, and then the inner adjustment moves the whole leg up and down like that. Really neat. The inner motor moves the whole leg, and then finally the whole robot is driven with these motors as wheels. Really, really neat. It's the most important part. Can I please show this?
No.
Oh. Okay, one of the cool things about this robot is the whole thing's powered by a Raspberry Pi. You can see right at the front of the little guy here, we have just a whole Raspberry Pi, which is pretty sweet. So this kind of is designed as a whole platform that you can add on to, you can write custom things for, you could put an arm on top, you could, I don't know, have lights. I don't know what you would do with this really, but I guess we'll try and find some uses for it. Let's see, we've got our whole power stage at the back here. These giant connecting cables that deliver power and data over to these motors here. Okay, so at the back here we've got, I guess this is a little LED bar. Look, you can see the individual units at the back there. So that must mean that we also have an LED bar up the front, but I don't know, we'll have a look. So yeah, you can see the whole power distribution system down here. Some big beefy motors coming from this gigantic battery pack. I mean, no wonder this weighs so much. So I'm gonna get these covers back on, and then I guess we'll turn the robot on and see if I can break it, myself, or the set. But you know, what never breaks is, but you know what never breaks? Our sponsor, Segways. Thanks to Moment for sponsoring this video. Are you a creative looking to make sure that you have the best gear to capture your vision? Moment is here to help, offering photo and video equipment for every occasion. Moment works with only the best brands such as Sony, Fujifilm, and Leica. They even produce their own high-quality gear. Go to the link below to check out Moment and their carefully curated catalog of gear. First take, Jesus fucking Christ.
One take wonder.
All right, I'm nervous. I didn't read the manual. Yeah. We have this giant safety switch on the back. So I'm gonna switch this and see what happens. Okay, everything's alight. Looks like we've got a light on the back. Got a light on the back. I don't know what to do. Okay. Let's be safe. Let's read the manual. You get an industrial piece of equipment and just YOLO it off the table. That sounds like a great idea. Now I'm scared. I'm going to enable the controller. Oh yeah. There we go. And then we should have a height adjust as well. The motion control on this is really good. Normally, when you have like a moving table like this, you would find that this happens, right? You get into like an oscillation situation because it's supposed to be on a stable ground, but it seems to be handling itself pretty well and recovers quickly. Move this back a little bit. This is a stupid thing to do. Let's try it on the ground. So let's turn it back on and actually go through some of the safety stuff. So there is an emergency stop procedure because, again, I mean, this thing is really rather dangerous and powerful. Obviously, you've got this giant button on the back, which you can kick down with your foot. There's also a control disable for the controller. So this right trigger here has about 3 positions. So we have controller disabled at the bottom position, we have low speed mode, and then we have high speed mode. You would hit this and then all control is disabled. On the left hand side here we have our creeping sort of down position, and then as we go higher it'll stand up, that sort of thing. We have another little rocker on the left hand side of the controller here which can adjust our height. So if we want to be down low, maybe get a better center of gravity, or come up. Geez, the controls are really responsive. These motors are extremely quick. Give it some Boston Dynamics, you know. Look, it comes right back to where it was. Stockholm Syndrome. It also has a jump mode. We're gonna stand back. If I push this button here, I don't know how to do it. Neat. Like a common controller, on the right here we have our forward and back, and then we also have turn in place. But on the left-hand side here, it's a little bit different because we have pitch control. So we can go up and down. And then it's also got the capability to lean left and right, which is kind of neat. It's so adorable, look at it. Unfortunately for me, the look up and down is like reversed. Like I want to drive it like an airplane and look up by pushing down. I don't know if that's a thing we can change. So in these 2 modes, it seems to be able to support a couple different kinds of weight. In this nice standing mode here, it should be able to support roughly 9 pounds. Oh, that does feel like a lot, but it might overheat the motors. These guys do tend to get a little bit warm. And then when it's in creeping mode like here, it should theoretically be able to withstand 170 pounds. Go in low speed mode here. So you can use it to carry like quite a bit of weight. If only it could carry the weight of my mistakes. Jump, please. A brokey. Direct Drive says that it can travel about 2 meters a second, which is about 4.5 miles an hour. That's a lot for a little guy like this. I told you I'd break the set, didn't I? There are Model RC cars that can go even faster than that, and I mean, those are pretty dangerous, but there's a lot of weight behind this. It can move a little bit unpredictably because it's self-balancing. You know, just pushing it around, it doesn't move like normal things, I would say. And with the latency between it moving its weight around and like actually stopping, it's very difficult to get it to respond in a safe or delicate way, I would say. So some caution is certainly required. Shall we take it outside? You want to go for a walk? Walkies? Huh?
Oh.
Do you want to go for a walk? You want to go outside? You want to go for walkies, huh? Okay, so I accidentally hit someone's car. I tried to get it up a curb and it freaked out a little bit. That's on me though.
Don't blame the robot.
Okay, let's see if I can get over this.
Oh, he's so strong. You jump over the wall.
What did I do wrong? Well, I had it in high speed mode. Okay, let's try another jump. Hey! Yeah, one of the neat things about having a center balance like this is we can, come on, there you go. We can get one wheel up on this. You can see the right-hand side leg is up farther than the other one. And then when it comes off, it just keeps standing. It should theoretically be able to keep its balance over a jump like this, so let's see. It did recover though. It's friggin' robust though. I mean, it survived me hitting that car with it, so I think this is good. Oh yeah. And I love that it automatically recovers itself like this. And I'm gonna jump up a curb. Okay, that's how I hit that car, but okay. What's neat is you can see it kind of auto-stabilizing itself because we're on a bit of an incline here. right?
Little victory dance. Oh.
Okay, let's try another jump. Okay, whatever. Okay, let's see how fast we can make it go. They're saying 2 meters a second. That might be in the like low down mode, but yeah, we'll try it. That's reasonably quick, I guess.
Is that high-speed mode?
Yeah, it's in high speed mode, but it's not in the crawl mode. So if we get it down into the crawl mode, I think it should go faster. That's maybe a little bit faster. It seems to be about the same speed in fast mode while it's standing or while it's in crawl mode, which is kind of, I guess that's fine. It feels a little bit slow when you're moving at like extremely long distances, but when it gets up next to you, it's kind of like intimidating and scary. Ow, bastard. Yeah, I don't know. The self-balancing and the robustness of whatever motion control system they've got in here seems to be really good. It's hard to get it to fail. It really is only hurting itself when we like make it do really dumb things. I mean, it's extremely quick and responsive, and you know, it can hold a lot of weight in this mode. It feels very, very sturdy. I'm impressed with the build quality of just about everything. The carbon fiber is certainly much more for rigidity, as it can hold its own weight if these were like steel or aluminum plates. It does seem to have some like 3D printed parts, but I guess that's kind of reasonable. It's not going to be a high run product, that's for sure. The motors are extremely responsive, extremely powerful. Yeah, it's tuned extremely well as well. It's quite a remarkable little thing. That's too much weight. Okay, well, that didn't work at all, but I'm pretty sure if you put a basket or something on it, it would probably be better than just balancing a bunch of wood on top of it. Let's head back inside and we'll look at it in a bit more detail. It's cool and it's really powerful and it works really very well for what it is. But my one question is kind of like, why? Why does it exist and what is there to do with it? I guess that's kind of left up to the user, right? Do you see something that would be useful to have this kind of self-balancing platform? As a learning tool, I'm not entirely sure it's 100% useful anyway. I mean, at the price of $3,900 US, it's a hell of a lot of money for this kind of platform. I mean, it does have 6 of these really powerful, direct drive motors. At $3,900 US, it's kind of a little bit large for somebody that's going to be just learning how maybe motion control systems like this actually function. The nice thing is that they've released a really involved and in-depth source developer kit, which means that you can interface with this robot in all sorts of different ways. You can access the current state of it and maybe where it is, and they even do another version that's even more expensive that has a full proper vision system. So you could, I don't know, maybe make a line following robot or have it follow trackers on the back of you or drive around the space in here. I don't know, lunch comes to logistics and Elijah and we put a basket on top of here, tell the robot to go to an editor and it just drives there. The problem is that the source code that runs all of this motion platform and this amazing performance of its ability to balance really well is closed source, at least it seems to be. And the source developer kit is available, but that's more just an interface with the software. I may be mistaken, but I can't find anything that lets you actually use this as a set of 6 motors and mess with it and learn. You could obviously write your own system, but that's extremely involved. Maybe as a tool for education, but at the high school level, the source developer kit, the SDK, is so complicated that it may be a little bit too advanced for high school kids. It's also really expensive. And if you look at the university level, maybe some engineering students want to be playing with dealing with a self-balancing robot, and your PID tuning kind of algorithms you can't touch. Then what are you doing? Maybe you're moving into mechatronics, so you might be using a real-world example platform to put an arm on it and interface with the CAN bus and serial that controls everything, but I don't know who it's for and I don't really know what I would want to do with it. Certainly this version, I'm sure people would have uses for a self-balancing robot like this, but it's kind of not as good as other platforms. It's kind of a weird middle ground. The thing is that these motors that it runs off of, these direct drive motors, are actually really incredible. Direct Drive Tech, I guess, started with their direct drive motors, and these seem really powerful. There's very little backlash. They don't twist or move. I'm going to cut my fingers off if I'm not careful. And they sell them individually. So this might be a good way to start experimenting with direct drive motors, maybe rip them off of here, use this as a kit. But I think what they might have done is, hey, we have all these motors. Let's put them in a platform that is fun and cool to look at, and maybe we'll get more attention for our direct drive motors. Saying all that, they've just announced a new pre-order for their more industrial version of this. Boston Dynamics has their Spot, and these self-balancing robots, as small as they are, they're quite robust in weird flooring situations, and they have a really tiny footprint. And so in an industrial application, moving things around quickly with full LiDAR and full awareness and maybe a little bit more power in the motors as well, quick change batteries, that sort of thing. I could see these as an automated delivery system between different departments for tools or parts or stuff like that. But for the everyday person, I'm not sure if it's anything more than a toy, even though it doesn't behave like a toy. If I could have this or the Apple Vision Pro, I mean, I'm not an Apple guy, but I'd probably buy the headset. I love that this is an open platform, but I just can't think of anything that we would use it for here besides delivering lunch. And even then, we'd need the $3,000 upgrade to be able to do that. Jesus Christ. Thanks so much for watching. If you want to watch more videos like this, we don't have any more. This is the only one we got. Don't forget to like, comment, and subscribe.